Have you ever wondered how many streaming jobs you can actually run on a Spark cluster? In this video, we're going to find that out live. I'll walk you through a real demo, share what I learned along the way, and leave you with the exact code so you can try it out for yourself. Hey, I'm Sony, also known as the Canadian Data Guy. I've spent the last 10 years between Amazon and Databricks. In the past 5 years, I've been hands down doing Spark streaming. My goal with the channel is very simple to give you practical, no fluff advice so you can confidently build and scale your own data pipelines in production. All right, let's dive in. I have a streaming job which has been running for the last 11 hours, and let's first start and see how the cluster is holding up. So, as you can see, it's been running about 12 hours or so. Let me open it up. So, if you click the metrics tab, it should show you all the hardware. And let me tell you, it's running on a very small machine. It's running on a single node machine with 8 cores. Let me show you this. So you can select a time frame. I selected a bigger time window. I'm showing you 9 hours of time window. And what you can see, CPU is around 50% plus, which is fantastic. Spark loves memory, so it used a lot of memory, which I gave it. That's okay. No problem here. Memory swap utilization, if you see, is going up. After some point, you should see it drop back. We call it a sawtooth pattern. Look here. So if you look at the free file system space, you will see this sawtooth pattern. This is all right. So I'm expecting in a few hours, it should happen for memory swap as well. And rest, you have other metrics here, received through network, transmitted through network, nothing really interesting. This usually just shows, hey, that some data is coming in and some data is going out of the node. And like I said, we are doing processing of 100 Spark streams on a single node. So 8 cores, that's all the hardware we have. Then I think you should try clicking the structured streaming tab. There are two ways to get here. One is you click the Spark UI. Once you open the Spark UI, you click the structured streaming tab once it opens up, and then you get to this page. Okay, now what is there to see here? So you can see 100 Spark streaming jobs that they have been running for 12 hours. I'm producing, for this demo, I produce 500 rows a second for each of these streams. Okay, so that's why you will see the average input is 499 point something, which is 500 rows a second. And then we are processing this data at a faster rate. Now let's open one of these streams so we can dive deep into that. Let's see. So you're seeing the input rate, which is 500 rows a second. You're seeing the process rate as about 1000 rows a second. And you will see the batch duration is around 8 to 10 seconds, right? Let me tell you where this is coming from and why is this important. You are creating a pipeline in Spark streaming. You get to choose the processing time. And this processing time defines how fast do we want a Spark stream to go. So on this one, I set it as 15 seconds. So what I'm asking Spark to do is run my Spark stream at every 15 seconds. Now let's connect the dots. If 500 by 15, you will get 7,500 rows a second. So what the graph is trying to say is I'm able to process 7,500 rows in about 8 to 10 seconds. If the stream was not keeping up, then the operation duration would be greater than 15 seconds. What we are saying, operation duration is 8 to 10 seconds. And we have said, hey, Spark streaming, try to run every 15 seconds. So what you can make out of this is that we are able to keep up, right? We asked for, hey, run every 15, but we have finished all our computation in 8 seconds. So this is what you want to see. Another way is your process rate should always be greater than the input rate. That's a sign that you have a healthy Spark streaming job running. Now let's get into the code. This code is ultra reusable. You can take out parts of it and basically do your own benchmark. It's totally modular, but let me walk you through the code quickly. We have some input parameters, which I have specified. I'm doing a scale test. I gave a number of parameters together and made it a config. So I'm saying run 100 streams, do 500 rows a second of input, try to do it every 15 seconds. And then these are some extra parameters. Okay. But you can alter these. So you don't have to create this. You can actually give one parameter at a time. That's all right. So you can do that. And then what I'm doing is basically this is just input parsing and parameter parsing. So here I'm saying, hey, I'm doing a scale test. This is the configuration I have selected. We are going to have 100 streams creating input data 500 rows a second. And the total throughput which we are trying to achieve is 50,000 rows a second. That's okay, it doesn't matter. Okay, now let's get into the code. Again, this is just config. All of this doesn't need to be there. This is more for, we are printing out all the information. So we're printing out the Spark version. We are printing out our connection type, all that stuff. But here is our code. So I'm using DLB data gen, which actually helps us create fake data. And here I'm creating IoT data. And basically all this code, what it does, it just helps me create like a data set at the scale which I want. So all of this is going on. And then I just have a loop. And this loop is basically helping me create like 100 streams. And here is where processing time comes in. Here I have set it 15 seconds. If your business requirement is, hey, we want data every 5 minutes, Spark is really good at throughput. It can do higher throughput very easily. So if your requirement is give me data every 5 minutes, then there's no point producing data every 15 seconds, right? Because every time you produce a file, you're going to commit that file, you're going to write that transaction in the Delta log. And then essentially you will have collected data only for say 15 seconds. It will be a very small file. Like in my case, I'm writing a file which has 7,500 records, 500 rows a second multiplied by 15. So if I make this 2 minutes, I'll write a fatter file. My Delta log would be smaller. My transaction history would be smaller. So it has much better effect on everything. Also, we'll use less compute because right now I'm running every 15 seconds, but I really don't need to. And I'm using compute every 15 seconds. Whereas if I run it every 2 minutes, then maybe my job finishes in 10 seconds. And then the next 1 minute, 50 seconds, CPU is free to do something else. And here, by the way, I have 100 streams looking for that compute. So I would really love to get some compute back. So when you're doing this test for yourself, I think the only thing you need to change is basically, this is the only piece of code which you need to change. Everything else can remain as is. This is also showing us some metrics which you can look at. There is some monitoring code which I have left here as well. So this actually tells, this also is doing monitoring that, let me show you. So basically it's checking, hey, how many streams are active? What is the throughput we are getting? What is the total runtime which we are getting? Those kinds of things. Yeah, more metrics. But realistically, whenever you're doing this for your own project, everything else can remain as is. All you need to alter is this part, which is define your stream input source and define your target. Here I'm writing into S3 location. That's all I'm doing. Okay. So let's get back. I wanted to show you one more thing. So the same notebook can also be like you can interactively run it. So what I did over here is this is the same notebook, by the way. And I wanted to show you this quick thing. So on Databricks, you have this variables tab. And in that variables tab, you can look at the actual value. So here is me running the same notebook. But here what I did was I changed the trigger intervals. Let me show it to you. So under config, you would see that I would have set the processing time as 60. Trigger interval 60. So yeah, so I actually set this number to 60 because I didn't want to actually, I don't need to process data this fast. Okay. So let's go here, same code. Now, if you look here, still popping up. Let's give it a second. Again, I can also go to the Spark UI and check it out. Okay. So here I said, hey, do processing of whatever data is outstanding every 60 seconds. So what you're seeing is it's able to wrap up its computation in 15 to 20 seconds. So whatever data, every minute it goes and sees, hey, how much data is outstanding and processes it. And it's saying, hey, I'm able to do that in 15 to 20 seconds. You can also look at this graph, right? So it's saying 12 seconds, 15 seconds, those kinds of things. Similar thing to see here, the process rate is much greater than the input rate. So my processing speed is 1600 rows a second. My input is 500 rows a second, meaning we are like 3x faster. If you contrast it with the 15-second trigger interval, here I was spending 7 or 8 seconds processing and then 7 seconds of sleep, and then I start over. Whereas here, what I'm saying is, if I run once every 60 seconds, it only takes me 15 seconds to process it. And then the rest of the time I'm done, Spark is free to do something else. So this is 25%. Like the requirement says, hey, process data every minute. I get done in 45 seconds are free. Now, if I stretch the example further, what I can tell you is that if I make this processing time to 2 minutes, what I'm going to probably find that I'm still done with my processing in 20 seconds. And then the rest of the time, the CPU is free to do something else. And imagine we have 100 streaming jobs going against 8 cores. So all of this is running on 8 cores. So I'm using our instance. What is the cost of RG2 extra large instance? Okay, so it's 40 cents an hour. So if you think about it, essentially you can process 100 streams or 100 tables, let's say, in less than $24 a day. Like I'm including both Databricks and AWS costs without discounts, everything, right? So being able to process 100 tables at less than $24 a day is like super amazing in my head. Okay, I hope you found value in this. I'll put the link to the code on the blog itself. So look in the video description and yeah, feel free to reach out to questions.